Hello and welcome to my presentation. My name is Reto Schölli and I will show you a little bit about our project, about what it does, about what it will be able to do, and how it may help some of you or some medical researchers to do their jobs. The project's name is MedSentinel, and it is a smart sentinel for biomedical online search, and I will demonstrate it a little bit by a COVID-19 search. This project is worked on by myself and by Philipp Kellmeyer and Suhail Yazici. One of the problems we face when we do medical scientific research is that there is a vast number of publications available. We have at least 860 ontologies, 860 classification systems for entities that may be of interest of medical research. There are about 12 million classifications around. And also we have 250 years of medical science. Our project, our MedSentinel, provides a web crawler that accesses databases such as BioPortal or PubMed or NLM catalog and combines them in its own little database. We found, or we are developing, an algorithm that allows us to find similarities between publications, meaning between the abstracts of the publications, and provide a list of topical similarities within medical publications. We can also draw graphs of those analyses. You may be aware that PubMed, for instance, already provides an excellent way to do research. They have an algorithm that provides a list of similar articles. How they do it is explained within an article on PubMed itself. And it's already a great tool to figure out which publications would be next of interest to your research interest. However, we go one step further, and I will explain you this within the duration of this publication. We are not trying to make something better. We're not saying that these databases do not already do a good job. They do. But we want to add something. We want to add something that makes research even more easy and comfortable, and also reduces the risk of one overlooking something. This is one of the views of one of the models. We have made this web crawler in a way that it can, by going online, update itself and always show the newest data entries. These data entries can also be compared and shown in a network, but we also have a list of available ontologies, can compare them with each other and find where they overlap and where they have similar entries, or where they maybe even have redundancies. I will show you this later. Also for PubMed, we have a tool that is able to fetch all of the articles and then compare them with each other, meaning comparing the abstracts with each other to find how similar they are and if they speak of the same thing. Our software compiles a list of all entries which fit a search criteria and compares the abstracts of those entries. And the rather new thing we do is that this comparison is carried out via SBERT sentence transformers, and it uses the Roberta large model. The abstracts are then compared with each other, or a similarity value is then generated using a cosine vector similarity model. And a similarity of 1.0 means an almost identical text, while 0 means no similarity at all. And after calculation, we store all these results in a Postgres database for future use. With this method, we have the ability to find similarities that may not show up in related articles or in citations, especially if the publications are from different medical departments that may not see each other's work. Again, this is not to criticize the status quo. We just want to add something and give a new tool to researchers and scientists. In this picture, you see that you don't see much. We have compared the COVID-19 ontology versus the COVID-19 infectious disease ontology and found similarities and disparities. The problem here is that you don't see much. It is a huge network that is, well, not very useful, to me at least. So after generating this network with the similarities between articles or ontologies, we can see them in a two-dimensional network, but we have also created a Unity 3D-based 3D network visualization system. Here you can load a file and see it in 3 dimensions. Just click on Open File. Then you can see the 3D network in all of its glory. If you hover over a node, you can see its title. And if you click on it, you can see the connection it has. And on the left-hand side, the article in question is opened if it's available on the database. You can also select its closest neighbors to see to which those nodes are connected. By clearing the selection and selecting another one, you can find interesting connections between different publications. And this is our current status of the project. We also are working on a virtual reality module that will enable us to fly through these universes of medical publications. Our special thanks goes to the IMBIT in Freiburg. It's the University of Freiburg Institute for Machine-Brain Interfacing Technology. And also we want to thank the Federal Ministry for Education and Research in Germany. Thank you very much for watching.